do x squared plus 1, and then x squared, x plus 1, and x minus 1.
Right. Okay, so first of all, of course, you sub in x equals 1 and it gets 0 over 0 first, okay? But then you factor the top. And you said that turned into x squared plus 1 and x squared minus 1?
No, x squared plus 1, and then you, then you just break x squared minus 1 into x plus 1.
Yeah. And that's what I'm going to do in a sec, right guys? So this turns into limit x approaches 1, x squared plus 1, x plus 1, x minus 1. Now remember, as you're going through here, if you're getting 0 over 0 or infinity over infinity, like think of what the problem is. The problem here is the x minus 1 in the denominator. You have to do something to get rid of it. And the first step is always to factor if you can. Read.
Yes.
What do you do now, please? I'll translate for those people watching at home. Okay, you shoot a laser at the board and magically that disappears. You cancel x minus 1 with the numerator and denominator. Dakota, what do you do now?
Well, in this case, I just kind of send in x times 1.
Good. So you get?
So you get 1 squared plus 1, bracket 1 plus 1.
Yep.
Which is just 2 times 2. Is 4.
And that's all there is to that one. This is a level routine of limits. This should be one that I expect everyone else to do in the class relatively nicely. Okay, right? There's no brain busting for that one. What you're going to find for limits, just like identities, if you start heading down the wrong way, feel free to erase and start over. Okay, I know there was one last night, I'm going to pick on Melody, we were working on during sewing class. Well, that's not the correct title. What's the title class? Fashion. Yeah, that sounds even better for me. I was in fashion class yesterday, as you can tell, with my fire today. And we were working through calculus problems. Okay, but anyway, the point was we were working on a question yesterday, and we were just working away. And then we just said, okay, well, let's just sub in the value and it worked. Right? Like, so that's what we should have done instantly, right? It would have saved us a whole bunch of stress and a whole bunch of everything else. Yeah. All right, let's keep moving here with, any question on that? Okay. Now, to be honest here, guys, if something's not clear, please stop me, because as you're well aware by now, I keep motoring on at 100 miles an hour if you do not stop me, okay? Robbie, you good?
Yes.
Yes.
So at the end of implementations, if you want to make a statement as x approaches 1, y approaches 4.
No, you don't have to. You can put that in if you want to, but no, I don't. You don't require it. You don't require that. We'll be doing, well, okay, let me rephrase. When we get to graphs, yes. When we get to graphs, yes, definitely. Okay, right, because we'll be doing more stuff right now. All right, so I'm going to go back to 5E, 5H, 5G6. Oh, goodness. Let's just do the whole sheet, shall we? 5E says, limits x approaches 3.
Which one is this?
5E off the home sheet. 3 minus root of 3x all over 3 minus x. All right. Who are we up to? Taylor, you can take it. What do you do for this one?
So, draft 5 root 3x.
Root 3x. Sounds good to me. So would you multiply this by that?
3 plus root 3x over 3 plus root 3.
Okay. There was somebody who asked me yesterday, I think it was Melody again, do you just do these all the same in substitution? No, you don't. They should all be a little bit of a mix, right? The way it'll work for your test, there'll be one substitution question probably, you know what I mean, one like this, one with factoring, one with infinity, there'll sort of be a little mix of everything. So you can't just say, are they all, you know what I mean? There's not just a set pattern.
Should identify which ones use which methods.
I have, all through the course.
Yes, but when we get, like, on the test, it should be, oh, this is the one.
No. Okay, so now then, Taylor. Sam, I think we're up to you. Can you show off your multiplication skills, please? Go ahead. Yeah, I'm probably gonna write this. I'll write this just for this, probably optional, but I'm gonna put it in here. And Sam went right to the next line, and that's fine by me. Okay, Matt, we're so close. What do you get so far? What should I do now, please?
Here on the 3 on the top.
Lovely. Limit x approaches 3. 3 times 3 minus x, all over 3 minus x, plus root of 3. Just for you guys here, hopefully you've been looking at this screen all boards, because we've been standing in front of you the whole year. So hopefully you're looking at that screen. Anyway, enough with that. Robert, what do I do now, please?
You can cancel the 3 minus x's.
Yeah, works on the level. We're left with limit x approaches 3, 3 over 3 plus root of 3x. Okay, Courtney, what do I do now, please?
7 through x.
Yep. So this is going to be
3 over 3 plus 9, which is 3 over 6.
okay, and please.
1 over 2.
I was going to make a big deal about fractions there. You know, I really was. I was going to say, no one in this class should leave it as 3 over 6, and then I messed it up there.
I tried substituting for that question, and it was pretty messy, yes.
And that's what you should sort of say to yourself as you're reading them. Like, if it doesn't, like this is why I said these are like identities. Once you get going in the right direction, just bam, 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 boom, and it works, right? Until you do it, you get mixed up a little bit. All right, 5G. This one is, okay. Yeah, this one, okay, this is Mr. Sadler being mean, actually. Okay, Courtney, I know what you just went, but I'm gonna pick on you here, because I'm just gonna tell a little backstory. The first day we did homework, there was a question similar to this. And you said, Mr. Sadler, why are you doing this? Why did you give us these? Remember with all these square roots and the rationalizing? And I said to you, I think, to show that you can factor things that don't look like they can be factored. With that said, Nick or anyone else, the numerator can be factored. How can the numerator be factored? Nick, no? No? That's okay. Matt, go ahead.
Turn into x plus root 5, x minus root 5?
Yes. And again, you know that it's just like a difference of squares, right? Now it's non-traditional, okay? Like this isn't one, you don't often do something like this. But as soon as you see that in the denominator, you gotta get rid of it, you can do that, right? Nick, why am I happy with that? Yeah, this just cancels it. Brianna, what do I do now, please? Okay, so this is just root 5 plus root 5, which is 2 root 5. Please don't tell me that's equal to 4.3829, whatever. Okay, please don't do that. It is just 2 root 5. Any questions? That was a little tricky. Like this one was a little cheap. Okay, but once you see it, though, like you gotta think. Always think of these questions just like identity numbers, like you wanted to look at the finish line. Think of what's causing the problem. The problem was x minus root 5 was the problem. How to get rid of that? You have to somehow get that in the numerator. Probably could have also, I'm not actually going to do this one out, but if you get into trouble, you probably could have done something like this. And got it to work out as well, too. That probably would have worked.
That's what I substituted for it.
And substitution will work, too, right? Like, any one of those will probably work, right? But for me, factoring, that's a neat little factor, I think. All right, we're up to H, 5H. Is, oh, this one just looks scary. Does this one just look scary?
Yeah, we're never gonna have it all.
I think this one just looks scary, but it might be wrong.
Once you sub in, it cancels out. It's really fast.
Okay. I'm gonna take Robbie's advice here, okay? I'm gonna, first of all, I'm gonna say, subbing in, give 0 over 0, so I haven't done that.
See, this is, I don't, because there's a lot of different parts to this, I don't know what to use as.
Yeah, there's a million different ways you could solve this. You could, what are some of the options, Robbie? You said you had an option, what were you gonna do?
Yeah, I combined the numerator first, and then I multiplied, or I got the x minus 9 and brought it up.
Okay, and that just worked.
And then, yeah, once I subbed in m equals root x, it worked out really nice.
Yeah, and the reason I'm thinking is I'm gonna do the substitution here right away because I don't like that square root x. Because I'm just thinking, tell you what I'm thinking when I'm going through this. When I change root of x, I'm gonna do this in a few steps. I'm gonna use s equals root of x because that's for Sadler. What's my equation? Caitlin, sorry, my mind was blanking. Caitlin, what's the equation going to turn into if I change s equal root of x? Okay. Now the reason that I went to this, because I thought with this line, why am I happy with the denominator now? Like, what does it look like it's going to happen to that long term? It's definitely going to be difference of squares long term. I see a 3 here, I see a 9, something's going to cancel with difference of squares, right? That's probably what's going to happen. Okay. Can I hit pause to give you guys a chance to try this one for those who don't ever done? Okay, for those who don't ever done, try and make that work. Okay.